Hello everyone. So today we are going to solve Leetcode problem 438, that is finding all anagrams in a string. So let's try to understand this problem by using this first example, and we will use the sliding window technique to understand this example, and then we will come here to code it out. We have two strings S and P, and we have to return an array of all the start indices of P's anagram in S. So an anagram is a rearrangement of the characters in a string. For example, for our P, an anagram could look like this, or maybe this, like anything. It should be a rearrangement, but the letters have to be used just once. So let's try to solve our problem. So we can solve this by using sliding window technique. So before we implement this technique, we need to keep one thing in mind, that the length of our P should be smaller than or equal to the length of S. Now that is because if our P's length would be more, then we would not find a single anagram, because let our S be AB. So our S length is smaller than P. How can we find an anagram in this string? So we will keep that in mind first when we will write our code. So leaving that, let's start our sliding window technique. So in this technique, when we start, like first we will have two hash maps. We will have two hash maps, S and P. So in our P, we will in our P hash map, we will keep a count of the characters in P. So we have got A1, B1 and C1, and for our S hash map, we would keep a count of the characters present in our S string. So for that, let's begin iterating through our S string. So in the beginning, we would start here, and our string would be this. So I have got C, I have got B, I have got A, and their count would look something like this. So once we see, so now we will see if our count of the string in S is equal to our count of string P. If that is true, then we will append this index, because this is the first index of our anagram. Like we can see the count is same, so we found an anagram. So what we will do is we will append that in our result. Let's write it here. So we have appended our first anagram index. Now in the sliding window technique, what we do is, as we iterate through the S string, we will move our this pointer. So now when we will move this, like we will slide through our string S, now this would be our next window. So in this, what we will do, when we shift our window, we will decrease the count of this character. We would decrease a count of this character, and if the character's count would be equal to 0, we will pop that character out. Now why do we do that? We will see that while we dry run through this problem. So now I have got B, I have got A, I have got E. So first what I will do is I will decrease the count of character S. So now it will be 0. And I have found another character which is E. So that would be 1. As I shifted, now I will see if my S count is equals to P count. Are my hash maps count same? They are not. So we won't be appending that. We won't be appending our this index into our result, because we don't have an anagram right now. Now we would shift even more. We would shift to this window. Now our pointer will be here. In this window, first we will do is we will decrease. Now as we have decreased it to 0, like in the previous dry run, as our C has become 0, we would have popped this out. Now this is popped out. Okay. Now this is popped out. We had BA. Now when I come to this when I come to this window, when I come to this window, I would pop, like my B's count would be decreased to 0, and as it becomes 0, it would be popping B out. So my B is now popped out, but I can see that I have found a B. So my B would now be 1. My B would now be 1. So I have got a AEB, and my S count is not equals to P count. So I would not put that into result. Now I would move to the next, like I would slide here. When I slide here, the same thing I will do with A. Like my A's count would be 0, and as it becomes 0, I would pop that out. I would pop that out, but then again I find my A, and its count would be 1 here. So again I found this. So my S and P are not same. Like I have got ABC's count here. I have got ABC's count here, but here I have got BAE. So then I'll slide to another window. Like now my counter would be shifted here. So in this, I would be popping E out. Like my E would be, first my E would be 0. From 1 it would be 0. And then I would pop E out. And I'll be adding, now in this example, if you see in this, there are 2 B's. So my B value would now be 2. So I have got 2 B's and a single A. The counts are not equal. We would not be appending it into result. So now we will move forward in our window, and it would start from ABA. So first we will decrease our count of B. Now here we will see why we were popping that out, when why we were popping the element out when it becomes 0. So now as our B has not become 0, we have just decreased its count. We have got B as 1. So as it is not 0, we will not be popping it out because we have B in this. We have got B in this window, and we have got another A. So we would be increasing A. So now I have got 2A and 1B. But is our S and P same? No, it is not same. So of course we will moving our window. Now it will start from here, BAC. Now this is our window. So now what will happen is we have got B. Now our A, in this our A's will be reduced. Now it will get 1. But as it is 1, it is not 0. We will not pop A out, but we will add C, as we have moved uh, through our string. So now we are adding C. So now I have got A1, B1, C1, and that is equal to, in P's, I have got the count same, like A1, B1 and C1. So this is where I am finding an anagram. So as the S count is equals to P count, what I will do is I will be appending this point, like this index. So what is the index? This is 0, 1, 2, 3, 4, 5 and 6. So I'll be appending 6 here. Now as I have appended 6, now I will move further to see if I am getting another anagram. So I'll just move further and it will just shift here. No, I have got ACD. I will have to remove B. So now as my count would be 0 of B, I would pop B out. I would pop B out. And then what I will do is I'll add D here. Now D would be 1. So I have got D1, A1 and C1, which is not, like my S count is not equals to P count. So I will not add this index. Like I will not add this index. So we just have result of 0 and 6. We cannot move the window further. Like we are at this point, we cannot move the window further because we don't have another element. like C and D. We don't have another element, so we cannot move the window further. So this is our approach for the sliding window technique, like how to get find all the anagrams in a string. So let's code it. Let's go to Leetcode and code this out and see how it works. Let's code whatever we have discussed. So first we will check our length of P. If greater than our length of S, then of course not a single anagram we will be finding, and we will returning an empty array. Then the next is to keep count, we will have two hash maps, that is P count and S count. After that, we will iterate through them and we will check the count. So through the length P for the first window, let's do that. So our P count would be this, and we are writing dot get because if our character would not be present, we would initializing 0, and if it is present, we will be increasing it by the count of 1. So S count, we will do the same thing. If it won't be present, it would be 0. If it would be present, we would increase its count by 1. After that, we will initialize our result array. So that would be our first index. If our P count will be equal to our S count, else it will just be a blank array. Then let's initialize our leftmost index, which we will be appending into our result array. Now what we will do is for I in range, now we will iterate through the whole array, like the rest of the array, by sliding our window. So in length of P, from length of P, we would iterate through the end of the array, that is through length of S. Sorry, I am saying array, through the length of the string S. So from length of P, we would do this through the length of S, and then in here we will be checking our S count, and we would increase it by 1. And then if the element would be there to slide our window to the right, so what we will do is the element in L, we have to remove that. So we will decrease its count. Now we will check if the count of that element, the L position, is equals to 0. If it will be equal to 0, we were popping that element out. So we would pop that out. And now we would increase our else position by 1, like we will be sliding our window. Then we would check if our S count is equals to P count in the end, and we would be appending to our result our position of that index, that is L, and in the end we will just return our result. So let's run this to see if we are getting any errors. So yeah, it's done. So in here you can see our time complexity would be something like O of n, because we are running through the loop once, and as there are 26 characters, it might be O of 26 as we are sliding through that. So let's try to submit this. Yeah, so that is done. Like this problem is done. So this is how we have understood, like to find all the anagrams in a string. This is how we can do that. So yeah, I'll see you in another video. Thank you for watching.